Here we go with section 2.3, day 1, the composition of functions. Composition of functions can look a little bit like this. Check this out. Let's say you wanted to change the temperature of boiling water. We know that in the Fahrenheit scale it's 212, but the question I have is, what is it in Celsius? We've got a formula that will help us do it. So if you just take 5/9 and then times 212, that's your input, the temperature is 212, subtract 32 and then multiply it by 5/9, then you get 100 degrees Celsius. That's the boiling point of water in Celsius. And then if you want to convert temperature from Celsius to Kelvin, what you have to do is you have to add 273. That will be 100 plus 273 Kelvin. So what do you get? The boiling point of water in Kelvin is 373 Kelvin. You could do the same thing for the nice cool day of 50 degrees Fahrenheit. If it's 50 outside, then in Celsius you could say it's 212 minus 32 times 5/9. And then what you get when you compute all of that, you get a 10 degrees Celsius. 10 degrees Celsius is the same thing as 283 Kelvin. And then even with the freezing point of water, you know that you can apply the same process. 32 degrees minus 32 degrees is 0. 5/9 times 0 is 0, so 0 degrees Celsius. And if you take 0 plus 273, and you get 273 Kelvin. One more time. And how about this time, instead of trying to do it in 2 steps, we just do it in like one big giant transformation. Let's try and skip the intermediary and go straight from Fahrenheit to Kelvin. What you'd have to do is you'd have to take that temperature and subtract 32, then just going through the order of operations. Then you'd have to multiply it by 5/9, and then you'd have to add 273. What I've done is I've produced a function that can go straight from Fahrenheit all the way to Kelvin. And in fact, when you plug in negative 460 into this one function, you do get out 0 degrees Kelvin, which is absolute 0. What I've just done is I've composed 2 functions together. This function, C of t and k of t, I've turned them into one function. I've composed them, and that's what we're doing today. We're working with composition of functions. So, check this out. Let's say that we've got, and here's how it looks. You've got 2 functions, one on the inside and one on the outside. Then you can compose them together. You call them the composition of f and g. And it might look a little bit like this. The composition, you read it like this. The composition of f in g of x. When x is 7, then, I'm just going to do it numerically one more time. You can see that you first have to put it into g. And that would be 2 times 7 minus 5. And you get 7. Well, no, 2 times 7 is 14 minus 5, which is 9. 9 is the output, g of x. G of 7 is 9. It's also the input here. So when we're going to put this in, we have to use 9 as the input. 9 was the old output, now it's the new input. 3 times 9 plus 8. When you do that, you get 62. So the composition of function, I've just taken, what I've really evaluated here is f, the composition of f in g of 7. And the answer is 62. What does that look like with just variables? So, if we are just going to do the composition of f in g of x, really what we're saying is we've got an f on the outside, we've got a g on the inside of x. And just to help you remember, it's in the same order. f of g of x. What is g of x again? I have it written down on your notes. It is, I'm going to replace this g of x with what it's defined with. It's x squared minus 3x plus 8. That's going to be the new input inside of f. And what is f? It's just 2 times its input minus 5. The input is going to be x squared minus 3x plus 8. And that's how you compose functions. All we really have to do now is simplify a little bit, combine the like terms. We get 2x squared minus 6x plus 16 from distribution minus 5. And then combining up those last terms, we get 2x squared minus 6x plus 11. And that is the composition of f in G. Let's do the reverse. Let's find the composition of G in f of x. Well, same idea. We're just going to have G of f of x, and then G of f of x. What is f of x again? It's just 2x minus 5. Let's take that as the new input and put it into G. G, remember, is the input squared minus 3 times the input plus 8. And so then we get, of course, the input is 2x minus 5, and the input over here is, again, 2x minus 5. We've got a whole lot of foiling to do and simplifying, but we can do it. We get 4x squared minus 20x plus 25 minus 6x plus 15 and plus 8. When we combine all these like terms, we eventually get 4x squared minus 26x plus 48. And that is your answer. That's the composition of G in f of x. So, part B, we've actually already done some of it. So you can see that we did this part right here. We got 7. That's because we substituted f, g, 7. What I want you to do right now is the other composition. Figure out what f of 7 is, and then put that into G. I want you to do this. Pause the video and try it right now. By the way, as your audio check, did you know that Des Moines is the capital of Iowa? I've driven through Des Moines once or twice, never really stopped in there. If you have a good Des Moines story, let me know. Here we go. Let's find the composition of G in G of 1. What that really means is we're going to find G of 1. Whatever that is, we're going to put that back into G. Remember, the function G is going to be 1 squared minus 3 times 1 plus 8. Just to simplify that down a little bit, because we can, 1 squared minus 3 plus 8 is 6. And now let's take G of 6, putting the old output back into G as the new input. This is going to be 6 squared minus 3 times 6 plus 8. And when you do all that, you get 26. Let's find the algebraic composition of f in f of x. So rewriting it, it's kind of like just taking f of x and putting it into f of x. What is f of x? We can substitute that middle part as just 2x minus 5. And then the function f is going to have a new input. It used to be x, now it's 2x minus 5. And then we get 4x minus 10 minus 5, 4x minus 15 is your final answer. Those are the end of the notes, so what I'd like you to do is start assignment 2C1. Copy the problem list and do the first problem. I will see you in class. Take care.